This is Ask Brock. I'm Brock Yorty. This week's question comes from Frank. Brock, I keep plugging my hydrocyclones. Please help. It happens. I can think of when I worked for Yorty and Son Well Drilling. Anytime that hydrocyclones started to shake and started coming out in that roping effect or wouldn't come out at all, what did we do? We took a screwdriver, we stuck it up in there, and we unscrewed that apex nut. We just let it run. As a matter of fact, I see photos and projects, and I've been on projects where I look up and there isn't an apex nut. And first and foremost, without that orifice and nut and the adjustment where we can actually tighten the solid size that we have as we screw it in clockwise, the hydrocyclone has stopped working. So let's get into it. First, is it roping and plugging up that way, or are we getting a large micron piece of gravel or whatnot into there? Because that seems to be our problem with this. Is if I'm running out of a mud pit or a pan and I'm using a gasoline pumper, or that hydrocyclone is running off of a centrifugal pump, we have some solid sizes that are getting sucked up in there and that can plug it. And we love to call it a 5-inch desander, but really 5 inch is a desilter. And we're looking somewhere between a 50 micron to a 70 micron. And there's what we call a D50 cut. So we want to make sure that our cones are running effectively and efficiently at 75 gallons a minute at 32 PSI. And yes, there's a lot of cones that come out of China and some other places now, and we have these discussions that they're all over the range of performance, and you should follow your recommended manufacturer's specifications. But we pull out the old school book right here, and go ahead, jump on and get it. It's very important. It's a great book. Let's pull out the whiteboard for a minute and understand that our solids control unit needs to be able to separate everything that is larger than 74 microns with a scalping screen, or we need to be able to have them settle out of the settling pit before they get in there and go through and plug up, where we end up taking that nut off the cone and losing it. So that's the first thing we need to think about. Now, if the cone is roping and that's where it looks like it's coming out like ice cream, and it's or this big like peanut butter type consistency, we need to understand that we have too much solids that are coming in for one cone. And that's when we start increasing our cones from 175 gallon a minute a cone to 2 to 3 to 4. And if I'm running a pump at 300 gallons a minute, I need to have a minimum of 4 cones that can cover what I'm trying to do, because our solids control is only as good as what our circulating volume can be. And that's very important for us to think about, is what is our circulating volume? Because we've lost the fundamentals. And again, it comes back to this type of stuff right here. We're a really great industry at doing and executing and tribal knowledge and taking that screwdriver and shoving it up in there into that cone. But dang it, a scalping screen that is 10, 20, 30 mesh is what we're using when we have an elliptical style shaker and the shaker's going down, and we're never going to be able to separate the large solids that should have been separated before we went into the settling tank. So that's why we get into high G linear shakers that can convey that stuff. We can have a tighter screen. We're not blinding off. And then when we get to that screen that we've decided to let the cones go across, 74 microns, it's 200 mesh. And I want you to think about that, to what screen size we're running there. And again, you can talk to your fluids engineers, you can talk to your solids control manufacturers, you can talk to all sorts of individuals that have the trials and tribulations. And then we get into what type of polymers and surfactants I want to be able to run across those screens and why I make it coarse. But you want to fix a big piece of this, stop treating our solids control units as if they're a one size fit all, that we don't need an extra amount of volume for circulating. or mixing or the rest of the pieces. And then we can have fully yielded drilling fluids and polymers that are mixed up that when they go in, they come across, they're not going to blind a screen. And obviously, we can get into many other pieces of this, but are we plugging because it is a rock or a large size particle? Or are we plugging because it's roping? If it's roping, we're adding more cones. If it's a rock, we need to get a scalping screen that can separate those larger size particles before they get sucked up into that cone, where we have that 80-20 cut. 80% is overflow, that's clean mud going back to the active system. 20% is concentrated solids that now has to go across the screen that is able to separate those solids, 200 mesh. Great question. Big discussion today. Get the book, Drilling Fluid Processing Handbook. Yeah, it's invaluable. Cheers.